All right, quick intro to logarithms. All right, we got our log form, and then we can also get our exponential form from that. So log form will be y equals log base b of x. Okay, I just chose those. So a couple things about restrictions on these. B, our base of that logarithm. B must be greater than 0, but B also cannot be equal to 1. All right, it's got to be greater than 0. It's got to be a positive number, but cannot be equal to 1. X, the argument of the log, has only one restriction. It's just got to be a positive number. Okay, so X has to be greater than 0. Cannot be negative, cannot be 0. You cannot take the log of a negative or take the log of 0. That'll come up quite a bit in solving with logarithms. Now, we can also rearrange this into an exponential form. That would be b raised to the y equals x if I'm using the same variables from this original log form here. Okay, so sometimes it's advantageous to go from one to the other based on the problem that you're doing. So there's our log form or our exponential form. Let's try rearranging a few of them with some different numbers. So we want to rewrite here in exponential form. So I've got my log form. I like to do this loop and swoop type of method that some people do. But you got to start with the base of the log. And then I'm going to go over to the answer, and it's going to equal 8. So if I do that, I've got 2 raised to the third power equals 8. That's my exponential form. And if you think about that, it's a true statement, right? 2 to the third is 8. All right. Now the other one, as you see, the log is on the left-hand side. Some people like this best. They rearrange it, they flip it around, and then they go to exponential form. So I'd have 4 raised to the second is equal to 1 over 16. And 4 to the second power is 16, so 4 to the negative second is the reciprocal of that, 1 over 16. Look at that. We just rewrote it in exponential form. Rock stars. Fantastic, folks. How about rewrite in log form? Shall we? I think we shall. So if I want to do that, I got my base of the log is, in this first one, 5 of 125 equals 3. So I have log base 5 of 125 is equal to 3, and that is a true statement. If you don't believe me, you can always type it in your calculator. Trust me. Trust me. All right, and the next one, again, we got base 1/9 of 729 equals negative 3. So log base 1/9 of 729 equals negative 3. You don't necessarily need those parentheses there, but I was trying, fractions get a little bit weird with the base and making sure you know what's in the log. All right, very cool. Now, one thing you might notice here is that the logs equal the exponents, right? We use logs to solve for exponents. That's one of the wonderful purposes of a log, right? So a log is an exponent. The answer to the logarithm is the exponent, and we're going to use those in both just algebraic type problems and also application problems in the future. And it's going to be awesome. It's going to be so cool, man.